So in today's lesson, you guys are going to be focusing on the one specific type of rigid transformation, which is called a reflection. A reflection is a transformation that produces that mirror image when a shape is reflected across a line. So when we take a look at triangle ABC is reflected across, well, reflected across the y-axis. And we kind of looked at this a little bit yesterday, but if you take a look at the points, you want to notice that the points are equidistant to the y axis. So, like if I would take a look at point A and count over to the y axis, it would be 8 units to, or I'm sorry, 7 units over to the y axis. Same thing if I counted from A prime, it would also be 7 units over to get to the y-axis. If I did the same thing with B and B prime, I would notice that that would be 3 units and 3 units to get there. And then for point C, I would notice that it would be 4 units and 4 units to get there. So it's equidistant on both sides of it. If you look at the ordered pairs, I have these actually all ready for you guys. One thing that you want to notice when you have a reflection across the y-axis is that all of the x values of the pre-image were negative. On our image, they all became opposite values. All of the y values, though, stayed the same. So if you want to get your answers rather than counting across the y-axis, counting is a very easy way to do it. But if you want a shortcut to get there a little bit faster, if I asked you to graph a reflection across a y-axis, the rule basically says if you have an ordered pair xy to get a reflection across the y-axis, what you're going to do is you're going to take the opposite of your x values and you're going to keep your y values the same. So that means whenever we have a reflection across the x-axis, our rules are going to change up a little bit and be the opposite. So again, notice that all of your points are equidistant from the x-axis. So if I counted from point A to the x-axis, it's 6 units. If I counted from A prime, same thing. I would do the same thing for B and B prime. It would be 6 units. If I counted from C and C prime, it would be 2 units. So again, that would be a way to find my line of reflection if I asked you to do something like that, just counting the same amount of units on both sides. But again, if you look at your vertices and you take a look at these points, you can see that the x values, -7, -3, and -4, are the same for both the pre-image and the image. The thing that changed up when you have a reflection across the x-axis are the y values. So you're going to notice that the y values become opposite and the x values stay the same. So if you don't feel like counting to the x-axis to make your image, the rule is to make a reflection across the x-axis, you are going to keep your x value the same and take the opposite of the y values. Now, another way, if I asked you to find that line of reflection or that mirrored line, so let's write that in, the line of reflection. Well, by looking at slope. So a reflection in a line of slope m is the transformation that maps point P prime so that the following properties are true. If point P is not on line M, then M is perpendicular bisector of P and P prime. If point P is on line M, then P is equal to P prime. So one thing, if you would notice here, if I took line M and I calculated its slope, if I also calculated this line here, you can see that this would be a perpendicular bisector, okay? So we would look at our slopes and we would find that we would have opposite reciprocals for slopes. And that would be another way to determine if you would have a line of reflection. Okay, if point P is on M, then we would actually have that would actually be on that line, and we would have that would equal one another. So it's a different type of scenario. You can see that we would have not necessarily this relationship, right? Where you don't have the point is on the line, but you would have the point actually following on the line. So we wouldn't have to worry about necessarily finding the line of reflection if it's actually on the line. Okay, so in this scenario, we want to graph the point on and then graph the type of reflection. So if we take a look at point J is at 3, 8. So let's plot that point, but then we also want to plot J prime with the reflection across the y-axis. So I'm going to show you again how to do that two different ways. So 3 over and then up 1, 2, 3, 4, 5, 6, 7, 8. Sorry for the extra marks. So there's 3, 8. So there's J. Okay, if I want to do a reflection or my mirror image across the y-axis, I can do this one of two ways. Remember, the y-axis is right here. So I want to think, how many places is it going to take me to get to the y-axis? It's 3 places. So I want to be equidistant on the other side, 1, 2, 3 places. So to make J prime, I would count over 3 places and write my ordered pair right there. So I could see that I'm going to be at, for my answer for J prime, I would be, and make sure you write J prime, -3, 8. To get there using the rule that we talked about, remember when you have a reflection across the y-axis, your x value goes opposite. So instead of having 3, we have -3, and our y value stays the same. Okay, now for the next one, let's graph 7, 4. And let's label that K. This one's a little bit different, and that's why I wanted to do this one with you guys. So it says for us to do a reflection in the line x equals 7. So it's not asking you to go across the x-axis, it's asking you to go across a particular line. So if you remember from algebra, we had a vertical line whenever you had an x equals problem. So if we're on this, let's draw out our line right now at x equals 7. Okay. And again, what we're trying to do right now is we need to graph the reflection. So this is actually going back to that rule that I was just kind of talking about. So because our point is actually on our line that we need to reflect it over, we would say that K is equal to K prime. So therefore, our value for K prime would still just be 7, 4 because our value of K is still on our line of reflection. And again, that goes back to that property that we were just talking about right here in step 2 here. If our point is on our line of reflection, we would just say that our new point would actually just be the same exact value. Okay, Let's see if you guys can practice these ones right now. We're going to do a triangle at points 0, 7, -2, 5, 4, -3. And let's do a reflection across the y-axis first on the first graph. Then I want you to plot the same triangle and do a reflection across the x-axis, okay? I do want you to graph the original triangle on both of those so that you can see what those look like. So let's graph our original triangles first, and then we're going to take a look at the coordinates also for the reflections on each. Okay, so if you're taking a look, these are what our original triangles would look like if you would graph them. If we just start to thinking about what the actual coordinates would be for a reflection across the y-axis, remember if we do a reflection across the y-axis, the y values stay the same, but our x values would be the opposite. Well, if I look at my first ordered pair, the y value would stay the same, the x value would be opposite. Well, the opposite of 0 would still just be 0. So A prime would be at 0, 7. B prime, well, the y value stays the same. The x value would be opposite. So instead of -2, it would be +2. And for C prime, -3 stays the same, but I have to go -4. So -4, -3 for C prime. So let's graph those ones. So here's A prime. And yes, it's the same because we're on our line of reflection for 2, 5. Be right here. And for C prime, be here. And again, if you didn't want to use the shortcut and you'd rather graph them first, you would be thinking about how many places is it going to take me to get to the y-axis. For A, I'm on the y-axis, so it's 0 places, so I'm literally graphing the same point. For B, it's taking me 2 places to get to the y-axis, so I would make my point 2 places on the other side. For C, it took me 3 places to get to the y-axis, so I would be going 3 places on the other side. Okay, let's do that now for the x-axis. Remember, the trick for the x-axis is you keep the x values the same, but you do opposite of the y values. And this is again on the original points. So 0, 7 would not be the same. It would stay 0, but 7 would turn into a -7, -2, and then it would turn into -5, and then 4, +3. So on this one, I'm going to show you that. So again, I'm 7 units to the x-axis. So if I wanted to go 1, 2, 3, 4, 5, 6, 7 units on the other side, that would get me A prime. I'm going to do that in a different color. So here's A prime. Okay, I'm going for B now. So I would be going 5 units down to get there. So 1, 2, 3, 4, 5 units here. And there's B prime. Now for C, we're going in the opposite direction, but I've got 1, 2, sorry guys, 3 units here. So I'd be going 1, 2, 3 units here, and I can make my point. And again, here's what your triangle would look like if you did a reflection across the x-axis. Okay, for the second part of today's lesson, you're going to be using reflections with line symmetry.